This is the P4 paper from October 2020. It's question number 9, which is the last question on the paper. This is an integration question, and in particular, we are going to be modelling with differential equations and solving differential equations here. So let's just read it through. Pretty standard sort of question. They're saying in this case, it's the area of a dish covered by bacteria. A is the area of a dish covered by bacteria. It's given by this differential equation. We're going to try and solve it given the fact that A is equal to 2.25 when T is equal to 3. So solving it, we need to get it into this format. The only thing I would be aware of just before I get started is that I'm going to try and get A equals when I'm actually going through and going to the point of solving the actual equation. But let's make a start on it. So they've said dA by dt is equal to, so dA by dt is equal to a to the 3 over 2 over 5t squared. So no problem with this first step. What I want to do is get all the t's onto one side and all the a's onto the other side, technique called separating the variables. So if I do that, I'm going to have dA over a to the 3 over 2. I wouldn't move the dA down, but I am going to move the dt up there, which gives me dt over 5t squared. And as soon as I get it into that situation, I can now just integrate both sides. Now, I'm not going to try and integrate them the way that they look at the moment. I'm just going to tidy them up. A to the 1 over a to the 3 over 2 is a to the minus 3 over 2 dA. So I'll be doing that integration, and on the other side, I'll be doing, well, I can take a fifth out. Let's just try and make things as easy as possible for myself. And 1 over t squared would be t to the minus 2 dt. So yeah, good to be able to integrate at this point. Not particularly complicated, I don't think. So add 1 onto the new power. Adding 1 onto minus 3 over 2 is going to make a to the minus a half. Add 1 onto power, divide by the new power. So divide by minus a half is the same as multiplying by minus 2. Do the same thing on the other side. Add 1 onto the power is going to make t to the minus 1. Divide by the new power will make that minus a fifth t to the minus 1. And obviously, we need a constant of integration there. But we don't have any worries about solving that constant of integration because we've got that information here. So a is equal to 2.25 when t is equal to 3. So when t is equal to 3, a is equal to 2.25. If I put that information in, then minus 2 lots of 2.5 to the minus a half is equal to minus a fifth of 3 to the minus 1 plus c. Work out those values and sort out what c is going to be. On my calculator, it came to minus 19 over 15. Once I've got minus 19 over 15, then I can go back to my answer here and say minus 2a to the minus a half is equal to minus a fifth t to the minus 1 minus 19 over 15. Now that's fine, but our answer, if you remember, needs to be in the format a equals up here. So don't get too panicky about it. Let's just see what we can do to tidy these things up. Well, first thing I can do is multiply everything by minus 1. Multiply everything by minus 1, I get 2a to the minus a half is equal to a fifth, sorry, in fact, let's tidy that up, is equal to 1 over 5t plus 19 over 15. Right, I can see a way of tidying this up and getting this sorted out now then. If I call 2a to the minus half 2 over a to the half, and on this right-hand side here, I can now combine those two fractions, can't I? I can just call them, common denominator for both of them will be 15t. So I can call that 3 over 15t plus 19t over 15t. Why am I doing that? Well, now that I've got 2 over a to the half is equal to just a single fraction here, 3 plus 19t all over 15t. What I'm going to do is just flip both of them upside down. If I flip both of them upside down, I'm going to get a to the minus half over 2 is equal to 15t over 3 plus 19t. Remember what I'm aiming towards. I'm trying to get a equals, well, the next step I'm going to get is a to the half equals by just multiplying everything by 2. So what's that? 30t over 3 plus 19t. And if I've got a to the half, if you just square both sides at this point, the answer is just going to fall out here. This is going to be great. I'm going to get a equals 30t over 3 plus 19t all squared. If we go back and look at what we were trying to do there, yeah, I've got P, I've got Q, and I've got R all sorted out in terms of the way that I've got that done there. So if you want to say P is equal to 30, Q is equal to whatever, you can do. I'm just going to leave it like that in terms of the length of the video here. So fantastic, I've got that first part done. And the second part, yeah, it's not too bad. 2 marks is just relatively standard sort of thing that they ask us to do. They're going to say, according to the model, there's a limit to the area. So what's happening is that this area is changing dA by dt, but the limit will happen when t is equal to infinity. Okay, as we get towards an infinite amount of time, what's happening to the area here? So that's all we need to put in for the limit. As t tends towards infinity, what are we going to get? Well, we're going to get a is equal to, put infinity in, so we're going to get 30 infinity all over 3 plus 19 lots of infinity squared. Right, well, if we do that, the 3 is completely irrelevant, so I get 30, and I'm taking a long time to do this, you could do it much, much quicker than this. We get that it would tend towards 30 infinity over 19 infinity. Well, they can cancel, can't they? So A is just going to tend towards whatever 30 over 19 squared is. Now, I think it said something about decimal places, so if you actually work that out, that works out to be 2.49, don't forget your units, centimetres squared. Oh no, it didn't say anything, so I suppose could have left it as the decimal. Good idea to put the units in though, and that's not bad for a question number 9, a last question there. That's relatively straightforward, I would say. Okay, hopefully that will make sense to you.